You use electricity every day. It's an essential part of our modern lives, powering everything from the lights in our homes to the devices we rely on for work and entertainment. You know it powers lights and runs your computer. But have you ever wondered how some devices keep running even when there's a brief power interruption? But did you know we can store electricity? We can. This stored electricity can be used to keep devices running smoothly. We do it with a cool thing called a capacitor. Capacitors are fascinating components that play a crucial role in many electronic circuits. A capacitor is like a little battery. However, unlike batteries, capacitors can charge and discharge electricity very quickly. It holds electricity for when you need it later. This makes them incredibly useful for stabilizing power supplies and smoothing out electrical noise. Capacitors are in many things like fans, where they help start the motor and keep it running efficiently. Phones, where they help manage power and ensure smooth operation. And even cars, where they are used in various systems including the ignition and electrical systems. Capacitors come in different sizes. Each size is designed for a specific application, from tiny ones in delicate electronics to large ones in industrial machinery. Some are tiny, like the ones in your phone. These small capacitors are essential for the compact and efficient design of modern gadgets. Some are big, like the ones in air conditioners. These larger capacitors are necessary for handling higher power requirements and ensuring reliable operation. But no matter the size, they all do the same thing: store electricity. This ability to store and release energy quickly makes capacitors indispensable in modern technology. What's inside a capacitor? Let's take a peek. Capacitors are fascinating components used in many electronic devices. They store electrical energy and release it when needed, much like a battery, but they work in a different way. A capacitor has two metal plates. These plates are crucial for the capacitor's ability to store and release energy. Imagine two pieces of aluminum foil. These metal plates can be made from various conductive materials, but aluminum is a common choice due to its excellent conductivity and lightweight properties. These plates are close together, but they don't touch. The small gap between them is essential for the capacitor's function. Between the plates is something called a dielectric. It's like a barrier. This dielectric material increases the capacitor's ability to store energy by preventing direct contact between the plates. The dielectric stops electricity from flowing between the plates. It allows the capacitor to build up a charge without letting the current pass directly through. It could be made of paper, plastic, or even air. The choice of dielectric material affects the capacitor's performance and suitability for different applications. Wires connect to the plates. These wires are the pathways for electrical energy to enter and exit the capacitor. These wires let the electricity flow in and out of the capacitor. When a voltage is applied, the capacitor charges up, storing energy in the electric field created between the plates. Think of it like a hose filling up a bucket. The capacitor fills up with electrical energy just like a bucket fills with water. The hose is the wire, and the bucket is the capacitor. This analogy helps to visualize how capacitors store and release energy in a controlled manner. Now let's see how it works. When electricity flows into a capacitor, it charges up and stores energy. This means it's storing energy, just like a battery does. The electricity builds up on the plates inside the capacitor. The dielectric between the plates stops the electricity from jumping across them. This separation is what allows the capacitor to store energy efficiently. When the capacitor releases energy, it discharges quickly. The stored electricity flows out of the plates and does work, like spinning a fan or lighting a bulb. It's like when you open a water faucet. The water stored in the pipes flows out immediately. Why are capacitors important in fans? Well, fans need a little extra boost to get going. This is because the motor inside the fan requires a significant amount of power to overcome inertia and start spinning. When you first turn on a fan, the motor needs a lot of power to start spinning. This initial surge of power is crucial for the fan blades to begin their rotation. That's where the capacitor comes in. The capacitor stores electrical energy and releases it in a quick burst to help the motor start. It releases a burst of energy to get the motor running. This burst is essential for overcoming the initial resistance and getting the fan blades to move. Without a capacitor, the fan might not start at all. The motor would struggle to gain the necessary momentum, and the fan blades would remain stationary. Capacitors also help keep the fan running smoothly. Once the fan is up and running, the capacitor continues to play a role in maintaining a steady flow of energy. They provide a steady flow of energy to the motor, preventing it from slowing down or stopping. This ensures that the fan operates efficiently and consistently. So next time you feel a cool breeze from a fan, thank a capacitor. It's the unsung hero that ensures your fan starts up quickly and runs smoothly, providing you with that refreshing airflow.